So we'll go to our next speaker, Paige Yeung. Paige, are you there?
Yeah.
Can you turn on your, okay, go on. So do you have a presentation to share? Can you try sharing your presentation?
Yes, I will share it. I will share it now.
The page will be, the title of her presentation is Facilitating Participant Engagement in a Virtual Exoplanet Research Workshop. The floor is yours, Paige. Go ahead.
Okay. Hello, everyone. My name is Paige Yeung, and today I'll be presenting on facilitating participant engagement in a virtual exoplanet research workshop. So I'll begin by talking about scientific literacy and public engagement in science, which are core principles behind this project. So scientific literacy is defined broadly as a public understanding of science. So having an understanding of how science is conducted and what scientists do. And the science I refer to here encompasses a broad range of scientific fields, including mathematical, natural, and social sciences. And scientific literacy is important because science is relevant to everyone's lives, and it's helpful for people to understand how real world science works and how they can partake in it. So a question that comes up in science education is how can we teach science in a way that promotes scientific literacy and encourages people to engage in science? To examine this question, we can first examine how traditional classroom science works. So traditional classroom science is usually textbook-based, and students usually follow set procedures to conduct lab experiments, complete assignments, and we can look at the teacher-student roles where teachers provide instruction and students complete assignments according to those instructions. And work is mostly done by individual students or group members working on short-term lab experiments. And traditional classroom science is divided into several broad fields as opposed to the very specific fields of scientific research. So we see that classroom science isn't very centered around real scientific inquiry, so we might consider a new model of learning. So we can ask ourselves what would be a model centered around real scientific inquiry. So we can turn to the inquiry-based model that we see in astronomy research seminars, which are taught at a variety of high schools, communities, and community colleges and universities. So what happens in them is that students conduct a research project over the course of a semester and publish in a journal. So you can say that they become scientists for a semester, and they often continue beyond that semester too. So each team focuses on a carefully selected area of research in astronomy and gets the opportunity to interact with professionals and join professional amateur communities. So there was a virtual version of this course that I took when I attended Stanford Online High School, where we worked online in teams. And personally coming in, I did not have much background knowledge of astronomy or astrophysics, but over the course of the semester, I got to work on a project involving exoplanets. And several of us in the seminar became involved with NASA's Exoplanet Watch, which is an amazing citizen science initiative that welcomes students and astronomers alike to their meetings and has helped and supported us greatly throughout our project. And we were processing data from transiting exoplanets for Exoplanet Watch. So we needed to process all these transit images, but each of them would be time consuming to process on an individual machine, and it took some time for us to handle the input files manually. So we wanted to create a way to automate this and have other people help us and the greater Exoplanet Watch community too process transit images on a larger scale. So the Exoplanet Research Workshop began as an effort to design a more student-centered model of learning based on the astronomy research seminars, where students conduct real scientific research, and also an effort to contribute more findings on transiting exoplanets to the Exoplanet Watch community. So we began as a group of students mentored by Colleen Talk from Stanford Online High School and supported by Exoplanet Watch. So in the workshop, leaders of the workshop serve as active collaborators on student projects, keeping in mind that participants should be going beyond processing exoplanet data to really understand the science and the scientific research process. So I'll go into several more features of our workshop for facilitating participant engagement, keeping students accountable, and overall getting the project to work. So first our platform. Our platform was easy to use. So we had Google Collaboratory notebooks with form fields set up so that students could enter inputs and process data on their computers without installing software. And we also recommended some research papers with background information for students to read about, and provided paper feedback to students who were writing them. And all these resources are accessible on a resource website for students to refer back to. And to provide some initial guidance, we had several preliminary large group meetings, which were recorded and then linked on our website, and then people split off to work in their own teams and host their individual team meeting with guidance from the leadership team of the Exoplanet Research Workshop. And also, like in astronomy research seminars, student projects were self-guided. So teams collaborate on Slack, and the leadership team for the Exoplanet Research Workshop advises each workshop team. And students received additional support from the greater Exoplanet Watch community, where they asked questions and had professional astronomers review their papers. And commitment levels are also flexible, so they had the option of either writing their own paper or just contributing data analysis to our larger study of one exoplanet, which I'll talk more about later. And additionally, this year, something new that we added was an application to participate in the workshop. This was so we provided resource documents for students to learn about exoplanets and the software that we used to make sure that they had a working knowledge of astronomy and are committed to working on the project. And this is to ensure student engagement. So currently we have 7 paper writing teams this year, along with another non-paper writing team. And the last feature I'll talk about, which I referred to earlier, is that participants had a co-authorship incentive. So they could choose to either just contribute findings to our larger exoplanet study or to write an additional paper on their own. So they can partake in real science in this way to develop a better understanding of the topics at hand, whichever option they chose. And again, they wrote a paper. They had a chance to work more with professional astronomers to conduct research, and they're more encouraged to pursue their project. So, in summary, for the features, workshop materials are accessible and easy to use. Projects are self-guided, and participants have a co-authorship incentive and get to partake in real science. As for our progress thus far and where we are now, so far more than 200 students have contributed to Exoplanet Watch through the Exoplanet Research Workshop. We previously presented at GHOU last year in 2020, as well as the GHOU fall meeting. And our paper from the workshop has been submitted to the Journal of the American Association of Variable Star Observers, or AAVSO. And we're currently working on publishing more resources for learning about astronomy research on our website, which is an ongoing project. And pages with our resources for getting started and for writing papers are linked here. Now we have more teams with papers in the works and many people who have contributed numerous hours of data processing to our Exoplanet project. And finally, this was all made possible by the Micro Observatory, a network of small telescopes that provided us with the data that we needed and is great with supporting amateur scientists. And we are also very grateful to the Exoplanet Watch community for their continued support. And that concludes my presentation. Thank you for listening. Feel free to ask any questions, and here's my contact information along with links to the Exoplanet Research Workshop, the workshop Slack, which you can feel free to join as a guest, and the Exoplanet Watch website.
Many thanks, Paige, for this wonderful work actually that you are engaged in and you are continuing on. This is great. I like it very much. So how long you've been in this, working on this project so far?
Been working on this for the past about 1.5 years. So we're currently in our second iteration.
Yeah, great achievement so far. Yeah, it's great. Do we have any questions? So in the Q&A, I don't have any question. There is comments here from Christian. He's saying that we'll definitely check that Exoplanet Research Workshop. Thank you, Paige, for this amazing talk. Yeah, indeed, it's an amazing talk and it's great work done by Paige. Yeah, Carl, you are raising your hand?
Great work, Paige. That's extraordinary.
So, Paige, how many people are working with you on this project?
I'm working. So currently we're working. So along with our advisor, I'm working with 2 other people right now. We are looking to expand our leadership team.
Mm-hmm. What are your future plans?
I'm not quite sure yet. I'm definitely going to continue pursuing this and looking into more of the citizen science projects that that really try to facilitate participant engagement.
I have another comment from Bianca. It says, looking forward to implementing these great ideas, great work. We still have some more time. So if there are no questions, maybe we could move to the next speaker. Well, thank you very much, Paige. Thank you for your talk.